Hello there, ladies, gentlemen, and Brandon. Welcome to the math tutorial of question 15. So in this question, it's talking about the points of O, so the origin is 0, 0, 0, A is that, and C is that, represented with three-dimensional space in this diagram. Okay, so if OABC forms a parallelogram in three-dimensional space, that means that you know that AB is the same length as O and C because of parallelogram, and that also means OA is the same length as BC. So determine the coordinates of B. In order to do that, you would just need to get this vector, you would treat it as if it's a vector from here to here, and move that up to here to there. So determine the coordinates of B. So from O to A is O to A is equal to the coordinates of A, because that's the coordinates from O. So that means it is -6, 2, -2. And from O to C is equal to 3, 1, 2. Now, in order to work out O to B, which is the same as just B because it's from the origin, that would equal OA plus OC, which means you would go, I'm going to do it in this form, just make it a bit easier. So you go -6, 2, and -2 in one bracket, where that's an x coordinate, y coordinate, z coordinate, plus OC, which is 3, 1, 2. And that would give the answer of -3, 3, and 0. So that means the final answer for this question, I'll just do it down here. I'll write A and S. B, the little arrow, B is equal to -3, 3, 0. All in bracket because it's coordinates. So that's question 15A complete. Now, determine the vector that represents OM. Okay, so OM is, how do I change the colors? Let's go. Pretty little pink color. It's from there up to there. Alright? Where M is the midpoint of BC. Okay, so in order to do this one, that's right, I'm doing it on the wrong touchpad. In order to do this one, you need to find out what BC actually is. And in order to do that, you just start it from, hold on, let me just double check this, just to make sure everything is going well. Okay, so yes, that was correct. So I need to go from vector B, let's move the mouse over, from vector B is equal to, let's change the pen back to black. Whoop, black. Alright, so the coordinates of B is equal to, which we just worked out, which was up here, -3, 3, and 0. So chuck them in one bracket. Next, the coordinates of C, which were given to us up the top, are 3, 1, 2. 3, 1, and 2. So in order to work out BC, you would have to add them together. So it would become BC is equal to, I'll put it back into this type of vertical equation just to make it a bit more simple. 3, 1, that's a very small one, 1 and 2, plus -3, 3, and 0. Oh my god, this is very hard to write on. So, which gives the answer of BC is equal to 0, 4, and 2. Okay, so from here, give me 1 second. Okay, now to continue this on, you can also write it down as BC Let me just pause this real quick. Let the interruption pass. Okay, let's get back to this. So BC is equal to 0, 4, and 2. Now that is this whole line here. So BC is this whole line here, right? The issue is we want to find this midpoint section. So in order to do that, we'd have to divide that whole BC line by... Okay, so you just want to divide that by 2. So I'll just do it just over here. It's a bit backwards, I know, sorry about that. But if I go... back. BC over 2 is equal to 0 over 2, 4 over 2, and 2 over 2, which means the midpoint of BC, the vector BC, is equal to 0, 2, and 1. So that right there is your final answer. That right there is the final answer. Just as it does say, determine the vector that OM represents OM. So OM basically means you just want to find the coordinates of M. And by finding the coordinates, O to anything, or the origin to anything, is just the coordinates. That's why that there is just the coordinates of A. But that is actually vector OA. So it's the same scenario. So in order to find the coordinates of M, we just found the coordinates of B, midpoint of vector BC, and then from the origin to those coordinates, that is the OM variable. That is why M is equal to that. Okay, now let's move on for the next question. This is where it gets a little bit more tricky. Determine vector, determine method. Okay, so let's move down to here. I'm just going to rub this out real quick. Okay, and if I pause. Okay, so let's resume. So, from the question, you can actually read that it says, let's get out of this black. Too far. Here we go. Determine the vector ON. So N is, oh my lord. Let's go back to pink. So N is here, right? And you want to determine the vector that goes along O to N. Okay. And then, if you keep reading, it tells you N divides AM in a 2-to-1 ratio. Now that is very, very important, that little bit of knowledge. So, if you look at AM is from, let's go different color, let's go purple. From here, across to here, okay? And it is across this way. Alright, now you want to determine that, and this might not seem that important, but it is because you know the vector of OA and you know the vector of OM now. We've worked both them out. Well, we were given A and we've worked out OM. So in order to do that, what you want to do from this point on is you're going to divide this vector and this vector up. Now you're going to divide it by 3, just because it gives you a 2-to-1 ratio. Now if it's 2-to-1, that means you can split it in 3 parts. So because it's, as you can see by the diagram, it is actually closer to M. That's why it's 2-to-1. Okay, which means we're going to reverse it here, and we're going to go 2 up towards M, and then 1 part towards A. Okay, that might not seem like it makes sense to you right now, but you'll understand it a bit better in a minute, hopefully. Okay, so I'll just rub that out. I only do that just so that you sort of understand what the question is asking and how to solve it, go about solving it. So in order to do it, you want to go determine the vector that represents ON. Okay, so you can see now that it's actually closer to A than it is to N. And just like in this scenario, we can move vectors to suit our needs as long as they stay in the same direction and as long as they stay in the same direction and generally the same magnitude. But in this case, what we're going to do is, so M goes all the way up to here, right? Say for instance, that's M there. And A goes all the way out this way. And we want to just find, say for instance, it's this point here. Now we're going to split m up into thirds. Sorry, that's m into thirds and a into thirds. Now we are actually going to use this part of m, which means we're going to actually only use 2/3 of m, and then so that will stay there. And then this last bit, this little, I'm just going to scribble it in green. This little green part for a is going to move up to here. And that is going to become that 1/3 of a. So our actual equation, instead of going m plus a, because that will give us a variable all the way up there, our new equation is actually going to be, so O to n is equal to 2/3 of vector OM plus 1/3 of vector OA. That is a bit hard to tell there, but I'll rewrite it down neatly. But yeah, so basically what we're doing is the 2/3 of this one plus 1/3 of that one. And we know that because it's split in a 2-to-1 ratio. So that's why it's going to be over 3. 2-to-1 adds up to 3. You split them into thirds. Okay. So let's scribble this stuff out. And let's go back to black and move down. And move down. Okay, determine the vector that represents ON. So ON is equal to 2/3 of OM plus 1/3 of OA. Now, I'm just going to write them over here. O to M vector and O to A vector is, O to A, if I remember correctly, -6, 2, and 1. Let me check that. -6, 2, and -2. So close. Shoot, wheel. -6, 2, and -2. And then vector O to M, which we worked out just here, is O, 2, and 1. Okay. So what we're going to do here is, let's just go 2/3 of 0, 2, and 1 plus 1/3 of -6, 2, and -2. If we expand it out, I don't actually know if this is a tech-free or tech-active thing, so I'm just going to do it all tech-free. You can do this in your head anyway. So this expanded out, that is obviously 0. 2/3 on 2, multiply the top, so that will become 4 on 3. 2/3 multiplied by 1, 2/3. So that's our first coordinates of OM, or the 2/3 of OM. And then this one, you're going to expand it out as well, so that becomes 1 on 3, so 1/3 of 6. -6 is actually -2. Don't need to do vector fractions for that one. This one here is 2 on 3. 2 on 3, and this one is -2 on 3. So now that you work them out, you want to add the x's and y's, x, y's, and j's together. So 0 plus -2 is -2. 4 on 3 plus 2 on 3, so it becomes 6 on 3, which is just equal to 2. And 2 on 3 plus -2 on 3 is 0. So O to M, or O to N, so vector of O to N is equal to -2, 2, and 0. That's all that question done. Now, I'm just going to get this and rub that bit out. Use a vector method to show that O, B, and N lie on a straight line. So if we go back up, that is from here into here into here. Now, the way we'd want to do that is we want to work out what OB is, which we have already done, which was here, -3, -3, 3, and 0. And then we want to work out what ON is, which is what we just worked out of -2, 2, and 0. I'm going to write them out here, see if you guys pick up on anything. So O to B is equal to -3, 3, 0. O to N is equal to negative 2, 2, and 0. So I'll give you guys a quick sec. See if you notice anything about these two vectors. I'm just going to continue over. Alright, so hopefully what you guys notice is that they are actually a scalar of each other. So if OB is actually equal to what? Okay, let's do it the other way around because I can't really be bothered to do that type of math in my brain right now without a calculator. ON, this is going to be easier, is actually equal to 2/3 of OB. Now, just to confirm that, we can write it out over here. So OB 2/3 of OB is equal to 2/3. Let's write out OB, negative 3 on 3. Wait, that's just negative 3. 3 and 0. Come down. Let's expand this out. So that becomes negative 6 on 3. That becomes 6 on 3 and 0. Negative 6 on 3 is negative 2. 6 on 3 is 2, and that is 0. So that there is actually, although it is 2/3 on OB, that is actually equal to ON here. Same variables. So you would go, and just by that you know that OB is actually a scalar of ON, and that's how you know that they lie on a straight line. If one vector is a scalar vector of another vector, all it really means is that this vector here might be ON, and then if I do purple, this vector here, which runs over the top, the exact same vector, but a bit longer, that one is OB. So by proving it is a scalar of, by proving O and B are scalar vectors of each other, that proves to you that they lie on the same line. Alright, well, thank you very much, everyone. Subscribe, like Mrs. channel. Everyone here has done a video, hopefully, so far. Sorry, it's a bit of a long one, but enjoy your night. Chuck it on ×2.